We're going to go ahead and look at exponential functions. An exponential function is where you have f of x equaling some number times a second number, and that second number is raised to a variable of x. Now, it's considered exponential because your variable is in the exponent. Whatever the exponent is on is considered b, and that has to be positive, and it cannot be equal to 1. So if b is positive and not equal to 1, it's considered to be an exponential function. So here we have two exponential functions, y equals 2 to the x, and in this case, a is 1 because there's nothing in front of the number that has a variable on it. And then we have y equals 1/2 to the x. So to graph this, I'm just going to make myself an xy chart, choose some numbers for x, and plug it in. So I take 3, plug it in, I get 2 cubed, and that's 8. Take 2, plug it in, 2 squared is 4. Take 1, plug it in, 2 to the first. Take 0, plug it in, I get 2 to the 0. Take -1, plug it in, I get 2 to the -1, which remember a negative exponent means 1 over that. Take -2, plug it in, I get 1 over 2 squared then, which is 1/4, and then plug in the -3. When I do that, and now plot these points, 3 to the left, up an eighth, 2 to the left, up a fourth, 1 to the left, up a half, over 0, up 1, 1 to the right, up 2, and so on, and draw in a smooth curve connecting them, I get this blue shape right here. This is known as an exponential function. When I do this one over here, if I take -3 and plug it in, remember that -3 exponent is going to flip the fraction upside down, so it becomes 2 and still just then to the third power, so that's 8. Take the -2 and plug it in. I would then have that 1/2. The -2 would cause that exponent to flip up, or the 1/2 to flip upside down, so it'd be a 2 squared, which is 4. Plug in the -1, I get 2. Plug in 0. Anything to the 0 power is 1. Plug in 1, doesn't change it. Plug in 2, I'd have a 1/2 squared, which is a 4th. Plug in 3, and I get an 1/8. Now I can plot these. 3 to the left, up 8. 2 to the left, up 4, and so on. When I do that, I get this. Very, very similar shape, but just going in the other direction. These are both referred to as exponential functions. The one on the left here is referred to as an exponential growth because as you go to the right, it goes up. Exponential growth, the b value always has to be larger than 1. So y equals, or f of x equals a times b to the x. If this b value, the thing that the x is on, is greater than 1, it'll be an exponential growth. Also, over here, this is an exponential decay because it is going down as we go to the right. Now, if our b value, the thing that the variable is on, the exponent is on, is between 0 and 1, it ends up being decay. Now, as a side note here, if you plug in 0, you get b to the 0, and anything to the 0 is 1. So you'd have 1 times a. And when you plug in 0, that's what you're trying to find for your y-intercept. So when it's in this form here, your y-intercept is a. So let's go ahead and decide if these are exponential growth or decay. The thing that your exponent is on is only the 3. It's larger than 1, so it's growth. Here, the only thing that your exponent is on is 4/3, which is still greater than 1. Not a whole lot greater than 1, but still greater than 1, so it is growth. Here we have 0.5 that our exponent is on. It is not greater than 1. It's between 0 and 1, so it's decay. Here, this requires us to go back to dealing with exponents from the other quarter. We have an exponent raised to an exponent. Remember, you have to multiply your exponents. And so you would get x to the 15th. On the right one over here, you are dividing. Remember, when you are dividing the same base, you need to subtract your exponents. So we have 3 of the root 3's minus 1 of the root 3's gives us an exponent of 2 of the root 3's.